are using Elixir, have used Elixir, are familiar with Elixir. At least a mix.exs file, right? Okay. So that's where we're going to start. That's kind of where it all comes together. So nerves, for those that don't know, is a system for building embedded Linux applications using Elixir/Erlang. It integrates into Mix, which is really nice. So you get a nice terminal autocomplete, and it's still pretty new. I think the current nerves is 0.6.1, so it's a constantly evolving system, but it's pretty bulletproof right now. So I'm going to go over a very basic system. We're going to implement Wi-Fi in a nerve system, which can be a little tricky, and we're going to be controlling this pretty little light we have here using this is a LifeX light bulb using a library I built in Elixir for their local LAN API. So first things first. Let me pull up the README really quick to GitHub. Don't want that to start. No. Oh, okay. Okay, so and nobody's following along, right? Nobody's going to try to run this or build it on a Raspberry Pi. We don't have much time, so it probably isn't going to be worth it. But today I went through and kind of updated the README so that when you get home or when you have some free time, you should be able to clone this repo and going through the README, get it running. I had a coworker run through it today and gave me some pointers, so it should be pretty easy to get this up and running if you have a Raspberry Pi and an SD card. So the first thing you're going to want to do is install nerves, right? So this gives you all your mix functions to build the firmware, to install projects, to create a project, all that kind of stuff. So it's an archive, so mix archive.install and clone the repo. What you're going to get is pretty bare bones Elixir project, just like anything else. But you will notice the mix.exs file is a little more complicated. First thing you're going to see is this target, right? We're going to build for the Raspberry Pi 2. They have systems for Raspberry Pi 3, BeagleBone. I think Intel Edison, but I think they might be dropping support for that. But there's a few other systems they support. If you go to nerves-project.org, there's a whole list of supported boards that you can build for. So when you create your project, you're going to tell it your target, right? Your target machine. So we're doing our Raspberry Pi 2, so it automatically creates this target for you. If you're going to do Raspberry Pi 3, again, it would be Raspberry Pi 3 here. So archives nerves bootstrap. It's going to tell it where to find some of the nerves files. It'll automatically download some pre-built binaries. You can go ahead and, we're not going to get into this now, you can build your own images. It uses buildroot and busybox. Busybox is the Linux kernel. Buildroot is a program for compiling and customizing busybox. So if you wanted, NTP is included, but if you wanted something like DNS mask or some more advanced features in your Linux kernel, you could enable them there and build your custom Linux image there. By default, busybox is extremely limited. Like I said, it has very few Wi-Fi drivers. I think for Raspberry Pi 2, they include 2 Raspberry Pi or Wi-Fi drivers by default. But again, that's just to keep the image slim. So if you have a custom Wi-Fi dongle, you would want to do a custom image and include the driver for that. So then you would customize this a little bit more. Your build path would probably be a little bit different as well. So next thing we're going to go to our dependencies. You can see we're going to include nerves. So I was wrong. It's actually nerves itself is 0.3. The Raspberry Pi 2 system is 0.6.1. So we've included that. Nerves interim Wi-Fi. So again, you can see how young it is. The Wi-Fi driver is the interim Wi-Fi driver. So it works, but it's very noisy. It has a lot of debugging messages and all that kind of stuff. MDNS, this is going to allow us to set a nice little custom name for it within our local network. and then obviously the LifeX library too, which we're not going to go into. I did a talk on that a couple months ago, but that is what's going to control this light bulb. And that uses a binary protocol, UDP broadcast messages, all that kind of fun stuff. And again, you want to make sure you start up all your applications. We've got Nerves and Nerve System, Raspberry Pi 2, MDNS, LifeX, our interim Wi-Fi, and obviously Logger, so we can log stuff. These aliases, I'm not exactly sure what they do, to be honest, but they provide kind of hooks for the mixed build and mixed firmware stuff to pull in the binaries. Like I said, a lot of this stuff, if you're just using a default Raspberry Pi 2 or Raspberry Pi 3, it's going to pull down a pre-built firmware as the base and then kind of inject your application into that. So that's that. So again, here, same thing as any Elixir app, right? We're gonna give it our start point, right? Our module, our application to start. So for here, we've got our LifeX controller. So if you pull that up in our lib, very basic. I know some people like to put their supervision tree kind of into their application using the import within their start function. As your applications get bigger, I like to separate the supervisors into their own files, so I tend to just start that way. So you can see all we do, we're going to throw a log message, we're going to start our LifeX controller, and we're going to start our supervisor. Everything should be under a supervision tree, right? So again, start link, we got our callback in it. Here, just some debug messages. The LifeX library, so this is going to provide a little web interface for controlling the LifeX bulb. The LifeX library actually includes that by default for testing. It's disabled by default, but you can enable it, which we have done in our config file. So we said, give us a TCP server and the port we want to run it on. So now we'll be able to hit localhost. Well, once it's on the Raspberry Pi, we'll be able to hit localhost, but when we're running locally, localhost 8800, we'll pull up our web interface. So we test to see if we've set our config file, or config variables correctly, and then we're going to set up our network listener. Thanks, guys. Okay, so probably the most complicated thing and hardest thing that makes it different than just writing your standard Elixir is, you know, when you're running on a server, you just assume your network is always available, right? Or at least when you install your code, your server's already up and running, the network interface is there, and you just go. Because this is a super bare bones Linux machine, you actually have to pull up your own network interface. So all your servers, if you're going to bind to UDP, which we do with the LifeX server, MDNS, we're going to bind to UDP and listen for broadcast messages on the MDNS port and IP. We need to wait until our network interface is up. So this whole app, again, majority of the hard work is done in the LifeX library. For this, I just wanted to show, you know, how do we bring up a network, respond to that, and then start an application, right? So a lot of the libraries I build around these embedded systems and nerves, the application itself will start, but any networking interfaces that we're gonna use require a second start command, usually within a server or a client interface or module. I will, once the network is up, I will say, okay, now, you know, create your network interface, whatever that may be. One for one, very simple. Okay, so network listener. This is a gen server, as most things should be. Require logger. So the other thing I like to do with these systems is, you know, burning an SD card for every little change and installing it on a Raspberry Pi and going back and forth gets extremely tedious. Went to ElixirConf, and I think Justin Schenk, one of the creators of Nerves, had a slide that he wrote the book on professional SD card swapping, because it is, I mean, it's just ridiculous. You burn, you swap, especially when you start embedding web interfaces on the Raspberry Pi, and you want to change some JavaScript, and you're compiling your JavaScript, burning that to an SD card. it gets ridiculous. So it's really nice to be able to build these systems and run them locally before you put them on the Raspberry Pi. Now that makes testing some of the network stuff a little tricky, but I think what I've got here is a pretty solid system for being able to switch back and forth by setting one environment variable, and I'll show you that. So here is the environment variable, nerves, right? So if we look at default.env, this is included in the repo. I'm going to have to show you guys my Wi-Fi credentials at work because I didn't get to change it before this. So we set up our interface. So on a VM, if you're running Linux in a VM, a lot of the times it's not going to be WLAN 0, right, or ETH 0. It's going to be some random DH something 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 0 1. So if that's the case, you can change that here. And now basically what it's going to say is, one, if you're running on nerves, it's going to tell it which interface to set up to listen for the network. But if you're not running on nerves, it's going to tell the system what interface to go get the IP address from, right? So if the network's already up, like MBNS, we need to be able to set the IP address to be able to respond to MBNS requests. So we want to be able to gather that IP address. So this is going to tell that what interface should I be listening to. ETH 0, WLAN 0, usually your kind of standard. Your SSID and your pre-shared key, this is for whatever network you're going to be deploying on. You would set that there. Obviously, if you're going to productionize this stuff, you probably want to build an app that goes into AP mode, allows you to set it to whatever network that device will be on for customers and stuff like that. And then our nerves variable, we set it to false here to run it. Okay, so we pull those all in. And now these get set during compile, right? So mix.deps.compile or even mix.firmware or mix firmware will run the compile step, and that all gets embedded there. So these are not runtime. So you need to enable your environment variables before you compile, before you build, because this gets built into the module in the compiler. Nerves interim Wi-Fi provides gen event to broadcast messages of what is happening on the network stack. So here our Wi-Fi handler is a gen event listener. So essentially we want to handle any event with this namespace, I'm not quite sure where this came from, and bound, meaning we have bound to an IP address to the network interface, or we have an IP. The send, I'll show you how that works. Basically, we pass in so we start link, again, very basic. This is kind of a singleton in OOP, right? So we can give it the name of itself because it is unique within the system. And we call init. So now we're starting nerves, or are we starting nerves, right? It says starting nerves, true or false. No matter what, we're going to add an event to the network interface. Yes, it does. We're going to add an event handler to the nerves network interface event manager. Wi-Fi handler, which was that module I showed you up above, and the argument self. So we're going to pass it. The PID of the network listener. And now what that does, if we look back at the Wi-Fi handler, init takes a parent, says the parent and the state, right? We reply with OK, and the parent is parent. So anytime it gets a bound event message, it's going to send that back to the parent. I'm not going to go into gen event too much, but essentially it is a process that's run. The handlers are run within the nerves network interface event handler. It's not ideal because there's no supervision tree. Gen stage is much better, but that's brand new. Blah, blah, blah. Anyways, and we're going to say. So we're going to send that back to the network listener and say, again, pass the bound atom with the info. So we then handle info. Okay, let's take a step back. Okay, so if we are in nerves, we need to start Wi-Fi first, right? That's going to start triggering all those event messages. If we're not, basically you put anything else but true if you're running locally. we're going to go get the IP based on that interface variable we set in our environment variables. We get our IP, ideally that works, sometimes it doesn't, maybe you got your interface wrong, maybe your network isn't up, sometimes you get nil, everything will crash and fail, or like flames come out. Just kidding. Start lifex, and then we start MDNS. I just threw MDNS in, it gives us a nice little, like I said, nice little URL to go to. So starting lifex, again, I told you I build in kind of a secondary start function for anything that's going to need to be bound to the network for embedded stuff. So here we call the lifex.client.start. That's going to immediately send out a broadcast message. This is on the lifex library. Immediately send out a broadcast message over the lifex protocol and look for any light bulbs on the local network. MDNS, we pass it the IP. We say, hey, here's your IP. We had our service, the domain. Again, so we're responding to A-type records basically for browser lookup. IP is a special atom that uses the IP that you used when you called set IP. This is nice. You can add your service once, and as your IP address might change, right, as your network comes up and down, or your DHCP lease goes up and down. You can listen to those bound messages, reset your IP, and you don't keep having to add service records and remove service records. It'll just use whatever the latest IP address is to return a result for MDNS. We don't need to go into the details of MDNS. TTL, 2 minutes, that's default for the MDNS spec. And then again, we say mdns.server.start. We know our network is up now, let's start our server. We need to wait for that broadcast message, right? But it's a very similar flow. But instead of saying, hey, just go get your IP, the network's already up, we need to say, okay, start Wi-Fi. So starting Wi-Fi is pretty simple. Again, some logging message just to let you know what interface and SSID we're gonna try to log into. nerves.interim.wifi, your interface, SSID. Key management's hard-coded here. Sometimes I include that in the environment variables. Depends. And then your pre-shared key for your network. And then boom, hopefully you got all that information right. It'll start booting up. Now some of the stuff that's really hard to debug is if your Wi-Fi driver failed to start. So I was initially trying to do this on the Raspberry Pi 3. That system isn't, the Nerves Raspberry Pi 3 system isn't rock solid yet. I think the majority of people and the core developers are still using Raspberry Pi 2 for all their products and projects. So there's some hacks. One guy's got it working in the Nerves Slack channel. I'm going to work on that, but I didn't have a ton of time, so I didn't get it working. And so, but I was going, what is going on, right? Everything boots up, and then it just says starting Wi-Fi, and nothing, right? No event messages, nothing happening. If you go up through your kernel log, there's a little bit of the Linux kernel log. You can see that there was errors loading the driver interface. So you just really got to pay attention. It's pretty much a silent failure. Kind of sucks. But when nothing's happening, look at your logs. Okay, so we should be up and running at this point. I'm gonna show you guys all our credentials. Oh shit, this is going on the internet too. We're gonna have to change these. And that's no moon. And we'll do nerves false for now. Okay, so I'm going to run this locally right now. WLAN 0, I'm on Wi-Fi, right? So I should be able to get my IP address on the local network here. Now I didn't have to change these right now because the SSID and PSK are really only for when you're building the firmware and flashing it to the Raspberry Pi. Running locally, it's going to use my local network, which is already, signed into the Wi-Fi, so we're good there. I've passed false. So let's source our environment variables. Okay, make sure we make sure that took. Cat satellite, okay, cool, no such file directory. Great. Let's do mix compile. So again, because I changed the environment variables, or setting the environment variables, I need to recompile those modules so that the at nerves, at interface, at SSID are all kind of built into the modules for the runtime. And I should be able to run ix-s.mix. Okay, so starting LifeX controller, we're starting the LifeX server because we set that in the config. We overrode the default for the LifeX app and said start the server. Starting nerves, we're not starting nerves, or we're not in a nerves environment. We're going to get our IP address for WLAN 0, which is 10.10.6.5, and starting the LifeX client. So I should be able to 10.10.10.5. Is that what it was? That's 65. 8800. Oh. Let's localhost. I guess 55. Yay. Okay. And the light changed, right? So again, this is just a little basic web interface here. Color isn't changing. Why isn't the color changing?
Press the circle thing.
Alright, network. Still on satellite. That also works. Last time I did the demo, the light bulb was really flaky on this network, and I'm not exactly sure why. I'm not going to blame their network, but it was also really hard to just get it on this time. Okay, that changed. Okay, there we go. So it dropped the network somehow. So we've got a nice little color slider here.
Chris, can I ask you what's oh, keep those to some info.
So yeah, the network seems really kind of slow right now. Okay. Anyways, okay, so that's working, right? This is running locally, but let's get it on a Raspberry Pi, right? So that's cool. We know it works. We can run it locally. Fantastic. Terminating WebSocket. So this is some log messages from the sample app here. Okay, so I have with me here a little Raspberry Pi. I've set this up to, and I'll go into this a little bit here, some of the configuration I did for nerves. But I basically got set this up so that the serial console, or the output from the console will come out over the Raspberry Pi GPIO serial interface. On Raspberry Pi 2, it's pretty easy. This is kind of default. I also set it so that the Elixir console is available over this, so that we don't need a keyboard, we don't need to run HDMI through this. We'll just be able to pull up screen through USB TTY0, our USB to serial interface. It'll be like we're just like we're on the machine. So I'll go through some of that configuration. Okay, so here, so this is where you can get into some of the customization, right? By default, you'll get a nice little system, but ideally you're going to have a monitor and a keyboard plugged into the Raspberry Pi to really make it useful. Since I knew I'd be on a single monitor and we'd be screen recording here, I didn't want to have to switch between HDMI inputs. I set it up, and it was a good way to kind of explain some of the customization that you can do here. So basically you can override. So Raspberry Pi has a few files that you can use to customize the kernel at boot up. The main one being commandline.txt. Now this happens to be the default for the Raspberry Pi 2. Raspberry Pi 3, that's not the case. If you want to do something similar, you would actually have to modify this file. But basically it's just saying, give us a console on TTY1, which is our HDMI output, but also output our console to TTY AMA0, which on the Raspberry Pi 2 is the default serial output. On the Raspberry Pi 3, that's actually what the Bluetooth, because it has built-in Bluetooth, that's actually what Bluetooth uses. So it's TTY-S0 on the Raspberry Pi. And then basically to give it our baud rate, where our root directory is, and root weight. I'm not exactly sure what that does, but that's your command line.txt. So what we've done in config.exs is given us the ability to override that. Now for that to really work, FWUP is the firmware updating system that one of the nerves, and firmware build system that one of the nerves core developers, Frank Hunleth, I'm not quite sure how to pronounce, Frank Hunleth developed, FWUP. And so this is a config file for this. And this is basically, looking at the file, it's a little complicated, but it's really not too bad. But it's basically setting up your boot partitions and all your different partitions. I've got 5 minutes, so I'm gonna go fast. You're gonna get buried kind of in this, but your main thing you're looking for is we want to be able to change that command line txt. So we need to tell the Nerves app where our customized command line.txt is. Now, this whole file, this is the only change I've made here. You can change the type of file system that you're building. You can change the size of your partitions. Just be careful. You can just corrupt your SD card and it'll be no good. And lots of other things, and just make an unusable system. But so this is the main point here, is the command line.txt, we want to change the root path for that, or the host path for that. So we've done that, so it's going to config RPI2, command line.txt. If we look at that, that's where it is, right? Config RPI2, and that's the root of that is your application directory, right? So your config directory RPI2, command line.txt. Now we're also overriding. So we also, in the config file, updated our root FS editions. Now this allows us to overwrite some of the files in the boot directory. In this case, to get the Elixir console over this serial console, I changed this from TTY1, which was just HDMI, to TTY AMA0. So now the Elixir console doesn't show up over HDMI, it's only available on our serial console. So just some of the configuration changes we did there. Again, that's done through these config variables here. So we are going to do mix firmware, build our firmware. So it's taking that base firmware image, updating with our Erlang releases. It uses the Erlang release manager for that. So again, I ran into this issue building some libraries. If you don't include some of your apps in your startup applications, it will remove. The release manager is smart and says, "Oh, this is just cruft," and remove it, and it won't be available. So like I think I did it with my MDNS library initially. I didn't actually start it in the mix.exs, and it just wasn't there. And I was like, "What the hell is going on?" It's a dependency, but it's not a running application. So the release library gets rid of it. Okay, so we built our firmware. I'm gonna unplug. Here's where we get good, right? Pull up my SD card, get my SD reader. Now, this is micro SD, so I've got a SD reader in my computer. We're gonna put our micro SD in here. This will show really quickly kind of the difference. So we get boot, app data, and 148. So app data is read-writable, boot is read-only. So some applications, Logger and a couple different things, some of the Erlang libraries, whatever's you need to write to disk, you're probably gonna have to configure that to write to the application partition. So it'll try to, by default, write to the local directory of your application, which is on the boot partition, which is read-only, so it's not gonna work. Okay, so we installed that, so now we're gonna do mix firmware.burn. fup, so this is using the FWUP command. It's pretty smart. It looks for like the smallest drive on your system, so it doesn't overwrite like your main disk. If you're very wary, there is a command line variable you can pass in to tell it the exact location of it, but it found the 30 gig thing, asked for sudo so it can write. We're writing. Okay, we're gonna install our SD card back in the Raspberry Pi. I'm gonna go ahead and start up screen. So that was just telling screen, hey, open up on our USB to serial interface. Work. Look at that, it worked. So that is okay. Getting IP entry. So here's an error. So I didn't change the source, right? We still had. It's crashing now, so it's going to restart. But we can see getting IP address for interface blank. It doesn't know the interface. It doesn't think it's on nerves, so it's false. So let's go back here. We will edit our .m file. True. What's going on? Okay. We're going to source our .m again. Let's see what does it think nerves is? True, great, mixed up stuff. Yep. File again. Mix firmware. Pull the SD card while we're building. Get very good at kind of being asynchronous with this stuff. Like, oh, I'm building. Okay, go pull your SD card. And I've noticed with my laptop, I have to pull the full SD card out and then back in to get it to read. I can't just pull out the micro SD card. I don't know why. Mixed up firmware to burn. Now, the one thing I wish I could do, and there might be a way to do this, is before I burn and all that, check that those environment variables got embedded into the firmware. I'm not sure how to do that. I wish there was a way, because it would save me a lot of time of like, oh shit, I forgot, and then...
just hook, check on a hook, I think. Alias hook?
There's probably a way to do it. Yes. Okay, we'll go back to... Yay! Okay, Wi-Fi's up. Got all the stuff. Okay, getting commit, sending discover. IP address bound, starting LifeX client. Okay, so Raspberry Pi now has 10.10.10. Now I'm not running locally anymore, right? I don't have, minimize that guy again. Right, this was running over here. Now we're, got the serial connection to the Raspberry Pi here. So let's go to, let's refresh this. All right, now we are running off the Raspberry Pi here. Let's see if it'll actually, there we go. Kind of changes. All right, this LifeX bulb does not like this network. So you guys can all hit this. I actually want to see what happens. Go to lifex.local. The other thing, if you have an Android phone, Android Chrome or any browser on Android does not support MDNS. It is really, really annoying. Chrome on iOS, totally fine. Any other browser on any other machine, totally fine.
What's the IP that we go to?
Go to Lifex. Do you have an Android?
Yeah.
10.10.10.110:8800.
Alright, buddy, so we're at time right now. If you had any questions, first of all, let's all thank Chris for coming out and speaking about nerves today.
And I'll throw